Okay. So factoring is much like what we've been doing, except that it works backwards. So we have actually been multiplying polynomials or monomials, right? Binomials together, things like that. Factoring takes a polynomial and it unmultiplies it. Basically, it writes it as a product again. So it takes a polynomial and it rewrites it as a product. So the steps for doing that, the number one most important thing is you always want to look for a GCF. That stands for greatest common factor, in case you guys forgot. You always want to look for greatest common factor. Okay. So I'm going to give you an example. If I had 2x squared minus 4x plus 6. If you think about that polynomial, what is the greatest common factor? Meaning, what is the same number or variable that I can take from each term? 2. Yeah, I could take a 2 out of each term. So when I do that, the GCF, the greatest common factor, goes outside. So I'm going to write it down here. It goes outside the parenthesis. And then I'm essentially dividing each term by 2. 2x squared divided by 2 is x squared. Negative 4x divided by 2 is negative 2x. And a positive 6 divided by 2 is a positive 3. Okay? So that's what we're going to work on today. We're just going to factor using greatest common factor, and then we're going to factor by grouping. That's probably my most favorite way to factor. Okay, so I want you to look at example number 1 and tell me, and I'm just going to write GCF off to the side so we can kind of put that out there. So tell me, what is the greatest common factor for number 1? Evan? It's a 7. That means I'm going to divide each one of these terms by 7. Now, just because you take it out doesn't mean it goes away. It's going to go outside of the parenthesis. Just like when we started multiplying polynomials, right? We had a number outside the parenthesis and we distributed it through. So 35x divided by 7 is 5x. And a positive 42 divided by 7 is a positive 6. Notice how I put emphasis on that positive because that's our plus, right? Does that make sense? Okay. Look at number 2. What do you think the greatest common factor is there? 9. Okay, let's try that. So I'm going to put a 9 out there, and I'm going to divide everything by 9. And when I divide everything by 9, I end up with 2x squared. 72 divided by 9, positive 8x. Negative 54 divided by 9 is a negative 6. It's 18. Yeah, so really we want to take everything and divide it by 18. Oh, stinker butt. So we want to divide everything by 18 because because right here we still have common factors. We still have a common factor of 2. Do you guys see that? So we're not going to divide everything by 18. So I have 18 on the outside. That gives me x squared, right? Because 18 divided by 18 is 1. 18 goes into 72 4 times, so 4x. And 54 divided by 18 is a negative 3. So half of everything that we had last time. So even if you choose the wrong factor at the beginning, like we did, if you see that you still have a common factor, that means you need to go back and find another one, okay? Typically, I just want to kind of remind you, we chose 9 and we ended up with 2x squared plus 8x minus 6. We were able to divide everything by 2 again, and 9 times 2 is the 18. That's kind of how you, like if you chose the wrong number, you see what you can divide by again and you multiply your last factor by that. We'll give you the new one, okay? Let's look at number 3. What's your greatest common factor? Say, I didn't hear. 3. Yeah, I agree. I think 3 is the greatest factor. So I'm dividing everything by 3. So I put it on the outside. Let's see. 9x squared divided by 3 is 3x squared. Negative 6x divided by 3 is negative 2x. And a positive 3 divided by a positive 3 is 1. Now, I would say probably the biggest mistake I see that when I see when we do stuff like this is this right here. I don't know why, but sometimes your brain tells you that 3 divided by 3 is 0 and you just leave it off. So watch for that. 3 divided by 3 is not 0, it's 1. So just kind of pay attention to that. What about example number 4? What do you think the greatest common factor is? I heard something. Say it loud, proud. 10. What else? Don't they both have an X and they both have one Y in them? Yeah, they do. So I'm going to divide every term by 10xy. So this is going to require me to think about, some of my exponent rules. So 10xy divided by 10xy, well, that's easy. That's 1. Negative 20 divided by 10, well, that's negative 2. But if I have x squared divided by x, let's see, that's a power of 2 minus 1, which gives me a power of 1. And if I have y squared divided by y, that's a 2 minus, remember when we divide, we subtract. Power of 2 minus the power of 1 is just a y again. Does that make sense? If you struggle with that, if you have a hard time processing that, remember that x squared is x times x, y squared is y times y, and you have an x and a y in the bottom. You can take an x off the top, an x off the bottom, a y off the top, a y off the bottom, and that leaves you with an xy. Okay? So if you forget the rule, you can always expand it. All right, let's look at example number 5. Greatest common factor, 9. 9x, yeah. We're going to take out a 9x. So I'm dividing both of these by 9x. So 9x squared divided by 9x is just x. 36x divided by 9x is positive 4. Yeah, good job. Okay. What do we think about this one? 4. 4 what? 4xz. Okay, you guys good with that? Okay, I'm going to divide everything by 4xz. Divide everything by 4xz. So let's see, 16 divided by 4 is 4. So I'm going to put my 4xz on the outside, and I have a 4 on the inside, minus, I see your hand, 40 divided by 4 is 10. X divided by x, those cancel out, right? Z squared divided by z is just z. What do I see with that? It's 8. Yeah, these can all be divided by 2, right? So it's really, really the greatest common factor is 8xz. 8xz. 4 divided by 2 is 2. Negative 10 divided by 2 is negative 5z. So do you see how I didn't redo that one? I just continued. I multiplied the 4 times the 2. I want to show you what I did. I multiplied this, what I had originally, times this to get this factor on the outside, and then just went ahead and did that division problem. Okay. All right. Notice they're getting not necessarily harder, but they have a lot more variable terms, going on. So what do you think about example number 7? 5, I agree with that. 5 what? How many x's are on each? Like what's the highest power of x? Yeah, 5x squared. Both of those contain at least an x squared, and both of those contain at least a y squared. So I'm going to take out a 5x squared, y squared, and I'm going to divide each by that. Okay. Do you need a pencil? Do you have a pencil? All right, so let's see. 35 divided by 5 is 7. And x squared cancels out. Y3 minus 2 is 1, so 7y. 45, positive 45 divided by 5 is a positive 9. X cubed minus x squared, well, 3 minus 2 is 1, and my y squared cancel out. Are you guys feeling okay about this? Some of you have this face like you want to vomit. You're good with it? Okay. You guys do number 8. I'm going to freeze the screen. You do number 8. I'm going to freeze the screen. Tell me when you think you're ready. McKinley, what'd you get? You can tell me what your greatest common factor was. That is what my greatest common factor was. So say your whole answer. So you have to start with the 6, the quantity. Good job. Minus 9 n squared, p squared. Perfect. You had it written right. You just didn't say it right. You're right on the money. Good job. That's excellent. So I actually started with 3. And then as soon as I did the 24 and I got an 8 and the 36 and got a 12, I was like, oh, it's got to be 6. And so I erased it. But yeah. Do you guys feel okay with that? Okay. So now let's talk about factoring by grouping. This is my most favorite method. And it's because you're able to group together polynomials, things with 4 terms, and find their like terms. And this method lends to factoring really, really well. So we recognize this type of problem, factoring by grouping, because they have like terms. And by that, I mean the constants typically are the same, or they have the same variables. So you're going to split the problem into 2 parentheses, 2 pairs, okay? And then you're going to see what you can take out of each. And if you do it right, if you split it right, the parentheses, the stuff that you have left in the parentheses will match. And that becomes your first binomial. And then what you took out of each becomes your second binomial. So let's look at this first example. I'm going to rewrite this kind of like this. So I'm going to write it as parenthesis x cubed plus x squared plus 2x plus 2. So let's look at the first parenthesis. What is a common factor that you could take out of the first parenthesis? I could take out an x squared. So I'm going to divide by x squared, divide by x squared. And when I do that, I have x squared times the quantity, let's see, x cubed divided by x squared is just x, and x squared divided by x squared is 1. Does that make sense? Okay. Now we're going to add that plus, what can we take out of this? A 2. And if I, not a 2x, because that last term doesn't have an x. So if I just take out a 2, let's see, 2x divided by 2 is x, and 2 divided by 2 is 1. So notice that these two sets of parentheses match. That means each one of those contains an x plus 1. Each one contains the binomial x plus 1. So that's my first term. Do you guys see how I wrote it up at the top? That becomes my first term. Times, you take what you have left over and match that together to become a parenthesis, your second term, times the quantity x squared plus 2. So this is what that factors out to. So here's a way to check this. Like, I'm not really sure. If I had used the FOIL method and re-multiplied those, you don't have to write this down. I just want to show you how to check. Let's see, x times x squared is x cubed. X times 2 is 2x. 1 times x squared is 1x squared. 1 times 2 is 2. So if I put these in order, x cubed plus x squared plus 2x plus 2, which is exactly what I started with. Okay? So if you think that you have it worked out and you're like, I'm not really sure, you can always FOIL to check it. You can always FOIL to check it. So I'm going to do the next one. I'm going to wait because I know some of you guys are writing down that check. That's awesome. So let's think about the next one. How do you want to group it? You want to try grouping it like this? Okay. So I'm going to rewrite it as 4a cubed plus 10a squared. And I'm going to write plus a negative 6a minus 15. Notice that the term, remember that the term includes the sign in front of it, right? So that negative goes with the 6, but I'm joining them with a plus because plus a negative is the same thing as minus. Yes, good job. Okay, so what can I take out of the first? 2. Yeah, I can take a 2a squared out. So when I do that, 2a squared divided by 2a squared. Let's see, 4 divided by 2 is 2. A cubed divided by a squared is just a. 10a squared divided by 2a squared is 5. Okay. Now I'm going to put a plus there. Tell me what I can take out of this one. A 3. Notice how both of those terms are what? Negative. How about if we take out a negative 3? So if I take out a negative 3, let's see, negative 6a divided by negative 3a. Well, a negative divided by a negative gives me a positive. Do you see how these match now? Negative 5 divided by negative 3 gives me a positive 5. Do you see how these match? So when both of your terms inside of the parenthesis are negative, that's kind of an indicator that you want to take out a negative, okay? So our final answer, I'm going to rewrite this. So I take the first, like this becomes my first term. We're just writing it once because I took it out of both. So I really have the parenthesis 2a plus 5 times the quantity 2a squared minus, I'm not going to write plus a negative, I'm just going to write it as minus 3. Okay. Right. So number 11, I'm going to group the 15x cubed plus the 3x squared together in a parenthesis plus 20 parenthesis 20x plus 4. So what can I take out of the first grouping? I can take out a 3x squared. So what does that leave me with? plus 1. Yeah, 3x squared divided by 3x squared is 1, right? So I have 3x squared times the quantity 5x plus 1. That's what I'm starting off with, okay? What can I take out of this next grouping? Take out a 4. Let's see. 20 divided by 4, 20x divided by 4 is 5x, and 4 divided by 4 is 1. So what's my final answer? Well, times the quantity. Perfect. Okay. How about if I let you guys try? I want half of you, let's see. Half of you, how about if we just do, there's way more girls in here than there are guys. How about if we do the front half? Okay. So if you are sitting in front of, or you are Lanaya, Kaylee, Sydney, Evan, or Jordis, you're going to do number 12. So if you're sitting in front of them, and then Riley, Michaela, and everyone behind her, which is nobody. Violet, everyone behind her. Courtney, everyone behind her. Macy, everyone behind her. Maria, everyone behind you are doing number 13. And I'll freeze it. Okay. Some of you are doing number 12. Some of you are doing number 13. Mm-hmm. But 4 also goes in. Yeah, you want the greatest common factor. Okay. Yeah, greatest. Yep, yep. So I just want to tell you something. When you make your groupings, if you can't see anything to take out of it, what does every term contain? A 1. Very good. Do y'all think you're ready? Need a little bit more time? Ready? Okay, let's take a look at them. So for number 12, I took out an x squared from the first grouping, and that left me with, I grouped them like this. Sorry, I didn't write that. This is how I grouped them. I took out an x squared from the first one. That left me with 2x plus 1. For the second grouping, 2x plus 1, I didn't have anything to take out, so I took out a 1. So I still have this common, right, which becomes my first term. And then my second term is x squared plus 1, because we have to turn it into 2 binomials. Does that make sense? Shake your head, yes or no. Okay. So if you weren't, ma'am. I always take the repeated factor. So the 2x plus 1, 2x plus 1, that I always make my first term. You don't have to do that, but it just is like a good system to get into. Okay. But you don't have to, because remember that 3 times 4 is the same thing as 4 times 3. You're still going to get the same result. Okay. All right. Number 13. I ended up with x minus 1 times the quantity 5x cubed minus 1. So I took a 5x cubed out of the first term, 5x to the fourth minus 5x cubed, and that left me with x minus 1. For the second one, I had a negative x, and I knew I needed a positive x, so I took out a negative 1, and I showed that. I wanted you to see that a negative x divided by a negative 1 is a positive x, but a positive 1 divided by a negative 1 is a negative 1. That gives me that same term. You have to have a repeated term, like that binomial has to repeat itself in the middle, or you have not factored it properly. Okay. Does that make sense? Okay. So for number 14, we're given a polynomial, 4 terms, and we have to find the dimensions of a rectangle. This represents the area of the rectangle. So this is going to be another grouping. So out of the first term, it looks like I can take out a 5x squared. Out of the second term, it looks like I can take out a 2. So 10 divided by 5 is 2. So I'm taking out a 5x squared. X. Negative 15x squared divided by 5x squared is negative 3. Do you guys see that? And then plus, if I take a 2 out, 4x divided by 2 is 2x, and a 6, negative 6 divided by 2 is a negative 3. So I have my repeated term. I put that first. That's my first binomial, multiplied by what I have left over, 5x squared plus 2. So if you think about this, this just means that the length, it doesn't matter, is, I'm going to say that the length is the 2x minus 3, and the width is 5x squared plus 2. And I really didn't need to put that in a parenthesis. Does it matter which one I call the length and which one I call the width? No, it does not. Okay? Absolutely not. Okay. So homework for today is pages 3 and 4. So you're factoring by pulling a GCF out of the first one, and then the second one you're doing factoring by grouping. Notice that the second assignment is only evens, so we're going to make the first assignment only odds. I'm going to do all of them just because I think it's good for you to see them, but you guys are doing page, oops, I have it on eraser. So you're doing page 3 odds, page 4 evens. Okay, I will do all of them. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20. So that's 20. Okay, are you good with that? 20 instead of 30? That should be fair.